Hi, I'm Landon. I'm going to tell you a joke. I wondered why the baseball was getting bigger and then it hit me.
All right, welcome to our work on trapezoids today. So this should be pretty quick. We've already done Riemann sums, and that had to do with rectangles. And now we're going to deal with a better approximation method. Well, usually better. That's trapezoids. So this is the trapezoid approximation method. And if I want to partition a region and use trapezoids, you will see how nicely this works. So if I want to take this region down here and break it into 4 sub-intervals, I'm going to have these 4 subintervals, and instead of drawing a cross to make a rectangle, I'm going to connect the left endpoint to the right endpoint and draw straight, and then that makes these trapezoids. And you can already tell that these trapezoids are going to be way better than the rectangles because I don't have a lot of missed area. So if we look at these, they don't really look like trapezoids. Like if I took this guy right here, it looks like this, which doesn't look a lot like a trapezoid, but if I turn this, it would look like a trapezoid kind of over there. So these are trapezoids, and what you really need to remember here is the area of a trapezoid formula is h over 2 times b1 plus b2. And in these trapezoids up here, this width right here is your height of your trapezoid because it's this distance, which becomes that distance. And these are b1 and b2. And this is B1 and B2, and then this is B1 and B2, B1, B2, B1, B2. So what we kind of notice here is when I do these trapezoids, my trapezoids have some repeated bases in them. So any base that's on the interior of my interval, I actually end up using twice. So I'm going to use that a little bit in a moment here. So let's draw and use 4 trapezoids here. That can be used to estimate the area between that graph that we used on the other notes from 1 to 3. So if I want to use 4 trapezoids here, and I connect these, there's my 4 trapezoids. I mean, could that be any prettier? I mean, maybe if it was a logarithm, but realistically, no, it's gorgeous. So we want to do trapezoids and estimate the area. Okay, so if I look at this, all of my widths are 0.5, and that's h. So h is 0.5 for every trapezoid. And so if I do my area estimate, I'm going to have h over 2, b1 plus b2. So that's going to be f of 1 plus f of 1.5. And then b1 plus b2, f of 1.5 plus f of 2. And then b1 plus b2, f of 2, f of 2.5, b1, b2, f of 2.5, f of 3. And you're probably already noticing that I'm duplicating some of those heights there. So my area is really 0.5 over 2, f of 1, plus 2, f of 1.5, plus 2, f of 2, plus 2, f of 2.5, plus f of 3. And now we're going to use that, and we're going to grab the calculator and let the calculator do some mathing for us. And let's see what happens here. So we have, let's see, what's my y equals? Oh, look, it's the function I already needed. Fantastic. So I need 0.5 over 2 times y1 of 1 plus 2 y1 of 1.5. I know, Landon, but I'm making a video, so I can't clean up cat barf right now. Plus 2. Yep, I know. Tessa's just barfing everywhere. This is a really entertaining video for you guys. I kind of want to delete this, but at the same time, it's at least entertaining. So plus 2y1 of 2. Let's see, did she barf on the boots? She did barf on the boots. I'll have to clean that momentarily. Plus, what's happening here? Plus 2y1 of 2, plus 2y1 of 2.5, plus y1 of 3 and I got 4.75. Okay. So where was it? 4.75. Phenomenal. All right, now it says estimate the area. And let's see, if I want to estimate the area, it's 4.75. Is this estimate over or under the real value? I'm not really sure. Well, I am sure, but think about it for a second. What do you think? Is it over or under? Overestimate. Who said that? It is an overestimate. If I take a look at this here, and I zoom in a bit, come on, screen, and I take this point and connect it to this point, and I draw the line, you can tell it kind of goes over, and like right here, it's even more obvious. Even if I only did half, it would be a little bit more obvious. So this is an overestimate, but what about the graph makes it an overestimate? Is it because it's increasing? No. It's because the curve of the graph is under the tangent line. It's not because it's increasing, it is because it's concave up. So this is, let me zoom it in here a little bit better. This is an overestimate because the graph is concave up. All right, so a function's concavity determines whether the trapezoids will yield an over or an under approximation. Whether the function is increasing or decreasing determines whether RRAM or LRAM is an overestimate or an underestimate. So trapezoids and their over versus under depends on concavity. Rectangles over and under depends on increasing versus decreasing. So if RRAM is used to estimate the area beneath y equals e to the x on a to b, so let's kind of sketch it here. Here's y equals e to the x. Then it would be, okay, so if I use RRAM, if I draw a rectangle and I use RRAM, RRAM would be an overestimate because y equals e to the x is, well, it is concave up, but it's also increasing. It's the increasing that makes it an overestimate when I'm dealing with rectangles. If using trapezoids to estimate the area from y equals e to the x, let's see, trapezoids then would be if I connect this right to that, I still have an overestimate because y equals e to the x is concave up. So rectangles, you look at increase versus decrease. Trapezoids, you look at concavity. All right, so what do I got next here? Estimate the area bound between the graphs of y equals ln x and all that stuff using 4 subintervals in the trapezoid method. Is this over or under? I'm going to let you do that and then come back. So I'm going to pause this for a second. I want you to sketch it on your own, figure out what the area would be, and then check with mine. Ready, set, pause. All right, so I really love this one. Why? Because there's logarithms. Yay! So I did logarithms here. And I said if we are going from 4 to 12 for our area, 4 to 12 is a width of 8, and I'm using 4 trapezoids, so they each have a height or a interval spacing of 2. So I did h over 2, b1 plus b2, and so on and so on. I doubled all my interior bases, and the exterior bases only happened once. And then I got really fancy when I typed it into my calculator because I wanted to. But you don't have to do that. And I used some log laws there, but basically I ended up with an answer of 16.218, and ln is concave down, making trapezoids an under approximation. And there you go. Now, one of the things we haven't seen yet is tables aren't really written with consistent intervals every time. Sometimes they are, but not always. So let's see what happens here. Some values for a function are given below. Estimate f prime of 3. All right, so f prime of 3 would be when we hug the point, and the closest I can get is between 1 and 5. So if I want to hug the point here, I'm going to do f of 5 minus f of 1 over 5 minus 1, which is 9 minus 5 over 4, which is 1. All right, so there's an estimate for f prime of 3. Estimate the area between f of x and the x-axis on the interval from 0 to 20 using LRAM and the 6 intervals given. Okay, so LRAM base times height. So my first base here goes from 0 to 1. So base times height for LRAM would be 4. My next interval goes from 1 to 5, which is a base of 4, and my height I'd use is 5. Then 5 to 9 is 4 again, and I'm going to use the height at 5. 9 to 11 is a base of 2 with a height of 12. 11 to 15 is a height of 4, pardon me, a base of 4 with a height of 15, and 15 to 20 is 5 times 19. So when I use LRAM, I'm using this interval right here, and then I'm using the left endpoint. So an interval from 0 to 1 has a width of 1 and a height of 4 for LRAM. From 1 to 5, that's 4 units, and I use the left endpoint to get my height, which is 5. And then I went forth and did that, so I have 4, 20, 36, 24, 60, and what's that, 95? It looks like 95. So let's see, what have I got here? 36 and 24 is 60, 120, 140, 235, 239, I think, if I mathed appropriately. All right, estimate the area between f of x and the x-axis on the interval from 0 to 20 using trapezoids and the 6 intervals given. Okay, so trapezoids, I'm going to do the same thing, except all of these right here are going to be my heights. So I have h over 2 b1 plus b2. Now I have a new height, 4 over 2, 5 plus 9, 4 over 2, 9 plus 12. Now see what I'm doing here? From 0 to 1, had a height of 1, and then my two bases were 4 and 5. And then 4 over 2, 5 and 9. And then another 4 over 2, 9 and 12. And now I've got 2 over 2, 12 and 15. And then 4 over 2, 15 and 19. And then what's this last one? 5 over 2, 19 and 20. And I don't feel like doing that in my head, so I have 1/2 of 9 plus 2 times 14 plus 2 times 21 plus 1 times 27 plus 2 times 34 plus 2.5 times 39. And I got 267, which is close to the 239, so I'm thinking I probably did it right. Alright, so last but not least, we have a nice little joke from Admiral Akbar coming up with Star Wars soon here. So, alright, and then one last joke is, what did the dog say when he got home from a long day at work? Boy, that was rough. Alright. I hope everybody had a wonderful Thanksgiving holiday, and if you're watching this video and it's not around Thanksgiving, then, you know, whatever, but hopefully you had a nice Thanksgiving holiday or are about to have one, depending on what time of year you watch this video, and have a great rest of your day.